Beneath the tranquil waters of the Baltic Sea, an extraordinary engineering marvel is quietly taking form. Spanning 18 kilometers, 11 miles, between Denmark and Germany, the Fearn Belt Tunnel is poised to become the longest immersed tunnel in the world. But this is more than just a record-breaking infrastructure project. It's a visionary step toward building a faster, more efficient, and environmentally sustainable Europe. Imagine cutting the travel time from Copenhagen to Hamburg to just 2.5 hours. Visualize freight trains traveling beneath the sea, where ferries once sailed. The Fearn Belt Tunnel is not merely concrete and cables, it's a symbol of innovation, cross-border collaboration, and the ambitious drive to reshape how Europe connects. A dream decades in the making. The notion of creating a fixed link across the Fearn Belt, a narrow strait in the Baltic Sea, has existed for decades. This body of water separates the Danish island of Lolland from Germany's Fehmarn Island. Historically, transportation between the two nations relied on a ferry route connecting Rødby, Denmark, and Puttgarden, Germany, a service established in the 1960s. While relatively effective, ferry travel has notable drawbacks. It's susceptible to weather delays, limited in capacity, and contributes to carbon emissions. As European integration deepened during the late 20th century, the idea of a permanent link gained traction. Economic cooperation between Denmark and Germany, coupled with increased labor mobility and trade within the EU, fueled the desire for a more direct and sustainable connection. By 2008, the vision began to solidify. Denmark and Germany signed a formal treaty, marking the beginning of a long and detailed planning process. Years of negotiations, environmental assessments, and technical evaluations followed, laying the groundwork for what would become one of Europe's most ambitious infrastructure ventures. Innovative engineering, immersed, not bored. Unlike tunnels drilled deep underground, the Fearn Belt Tunnel is being constructed as an immersed tunnel. This method involves building massive concrete sections on land, floating them into position, and submerging them into a dredged trench on the seabed. It's a strategy that enables higher quality control and faster construction, especially in shallow marine environments. A total of 89 standard tunnel elements, each measuring around 217 meters in length, 42 meters in width, and 9 meters in height, will make up the tunnel. These sections are produced in a specially constructed facility in Rødby, Denmark, which is now the largest tunnel factory in the world. Together with its adjoining work harbor, the site covers over 220 hectares, the size of more than 300 football fields. Inside the tunnel, travelers will find a dual-lane motorway in each direction and a twin-track electrified railway. These will be separated by a central service corridor, which ensures safety, maintenance access, and emergency readiness. State-of-the-art systems for ventilation, lighting, drainage, and safety are also being integrated into the infrastructure, designed to accommodate both high-speed passenger trains and heavy freight traffic. A massive undertaking, the tunnel is being built under the supervision of Fearn AS, a subsidiary of the Danish government-owned Sund and Bælt Holding, with a price tag of roughly 7.1 billion euros, equivalent to around $7.7 billion. It ranks among the most expensive civil engineering projects in European history. Denmark is taking primary responsibility for funding the project, primarily through government-backed loans. While construction officially broke ground in 2020, substantial preparatory work, including sea dredging and landside development, began in 2021 after overcoming environmental hurdles and legal challenges. One of the earliest and most intensive phases involved excavating a massive trench on the seabed. More than 15 million cubic meters of soil, rock, and sand were removed to create the tunnel's path. These materials are being reused to form new natural reserves and recreational areas, particularly near Rødby, enhancing both ecology and public access. Once each tunnel segment is completed, it is floated out of the factory, towed into the Baltic Sea, and gently lowered into position with precision. This operation demands coordination between naval engineers, crane operators, and technical crews, as even a small misalignment can compromise the tunnel's integrity. The tunnel sections are connected with watertight gaskets and reinforced sealing systems before being integrated into the broader road and rail networks on land. Navigating complex challenges. Constructing an immersed tunnel beneath a busy sea strait comes with its fair share of technical challenges. The marine environment places extreme demands on both the construction process and the final structure. Engineers must account for variables such as underwater pressure, temperature fluctuations, seismic activity, and the potential impact of passing ships. Precision is paramount. Improper placement of even a single section can lead to structural instability or leaks. To address this, the project uses advanced simulation software, extensive modeling, and materials tested to withstand extreme conditions. Moreover, aligning construction efforts across two countries brings logistical and administrative hurdles. Differing regulatory standards, labor rules, and project timelines require close bilateral cooperation. Despite these complexities, Danish and German teams are working in tandem to keep the timeline on track, with the tunnel scheduled to open in 2029. Pioneering innovation in construction. The Fearn Belt Tunnel is pushing the boundaries of construction technology. By opting for a factory-based manufacturing approach, engineers can ensure tighter quality control and more sustainable production. Factory automation and robotic inspection tools are increasingly used to reduce human risk and increase precision. Digital tools, such as building information modeling, play a central role in managing the project. Building information modeling creates a shared 3D digital twin of the tunnel, allowing architects, engineers, and contractors to collaborate in real time. It integrates data on materials, construction timelines, environmental impact, and costs, making the process smarter and more efficient. The project is also setting environmental benchmarks. The reuse of dredged materials, ecological restoration around construction zones, and commitment to shifting freight from road to rail all contribute to a greener outcome. The tunnel is designed not just to serve modern transit needs, but to align with the EU's broader climate strategy. How it stacks up. The Fearn Belt Tunnel is often compared to other major European infrastructure efforts, like the Øresund Bridge, connecting Denmark and Sweden, and the Channel Tunnel, linking the UK and France. While each of these projects revolutionize transportation in their own way, the Fearn Link stands apart in both construction technique and environmental approach. The Øresund Link combines a bridge and a tunnel, while the Channel Tunnel was bored through bedrock. In contrast, the Fearn Belt Tunnel uses fully immersed, prefabricated segments ideal for the shallow but broad Baltic Strait. This method is not only quicker and more cost-effective in such environments, but it also allows for rapid scaling of production and meticulous quality assurance. Beyond technical differences, the Fearn project carries deep symbolic value. It's a physical expression of European unity, integration, and cooperation. Funded and executed jointly by two nations, but backed and supported by EU frameworks, the tunnel underscores the importance of transnational infrastructure in a connected continent. Economic and regional transformation. The tunnel's benefits extend well beyond transportation. By replacing ferry services, it will dramatically reduce travel times. A car journey that previously required a 45-minute ferry ride, excluding waiting, will now take only 10 minutes through the tunnel. Rail trips between Hamburg and Copenhagen will be shortened by 2 hours, making train travel a far more attractive alternative to short-haul flights. This efficiency boost is expected to unlock new economic potential across Northern Europe. The tunnel forms part of the Trans-European Transport Network, an EU initiative to streamline connectivity across the continent. Improved access is likely to increase cross-border trade, drive investments, and support regional development. Towns and regions on both sides of the link, such as Lolland in Denmark and Schleswig-Holstein in Germany, stand to gain from increased infrastructure spending, job creation, and tourism. Enhanced mobility will also foster labor exchange and business collaboration across national lines. And there you have it, the incredible story of the Fearn Belt Tunnel. a true masterpiece of engineering and international collaboration that's shaping the future of Europe one tunnel segment at a time. If you found this deep dive as fascinating as we did, make sure to smash that like and don't forget to subscribe. Until next time, stay curious, stay inspired, and we'll see you in the next video.